All right, this is going to be a video recapping this entire unit. So feel free to watch this video to be able to catch up. I'm going to be going over old notes, so I would definitely recommend pulling out copies of those notes to follow along with it. And here we go. So I want to start off with a couple of key features of quadratic functions. Those key features include things like the vertex, the shape, the y-intercept, and the roots or zeros. So vertex is going to be, vertex is the point that is either the max or the min. Max or min. In a second, we'll remind us how to find vertex, but let me go through the rest of these first. So the point that is the max or the minimum means the highest point or the lowest point. The shape, when I say shape, I usually mean is it curved up like a smiley face or is it curved down like a frowny face? So this is which direction does it curve? And this is very useful to be able to find out which equation goes with which graph, if I provide you both of those and need you to match them. The y-intercept, just like with linear functions, the y-intercept is where the line touches the y-axis. And the roots, or zeros, are just other words for the x-intercepts, which is where the line touches the x-axis. As a quick reminder, there is only ever one y-intercept. There's always exactly one y-intercept. For parabolas, though, with their roots or their zeros or the x-intercepts, there can actually be either 1, 2, or 0. So for example, if I was drawing, I'll show you that example later on. So what we're going to do is use these 4 features to be able to find out information about a graph based on an equation. So let's look at these. What I'm asking us for here is tell me about the shape, tell me about the y-intercept, tell me about the vertex. So quick reminder about the shape. The shape is dependent on the a term. So this number right here, our first number is a. A is what determines the shape. If a is positive, then it's going to be smile, like positive, it's positive. So if a is positive, like this one, then it's going to be a U shape. If a is negative, then it's going to be like a frowny shape. All right, so we know the shape. We can actually figure out the shape of these and the shape of these. I'll go over those in a second, though. Y-intercept is also pretty easy to find just by looking. The y-intercept is c, or that constant. So this right here, c, is our y-intercept. So this says that we're going to intersect at 3. Now for the tricky one. Not really tricky, but one that actually requires a little bit more work and writing. Let me change to a different color so this doesn't get as confusing. So to find the vertex, what we need to do is use our vertex equation, which is, vertex is the x part of the vertex. Remember, the vertex is a point, so it's going to be like an x and a y. The x part you find by doing the opposite of b over 2 times a. And you find the y part by plugging it in. All right, so let's take a look at this one. In this case, the x part is the opposite of b, so b here is 7, the opposite of 7 is negative 7, over 2 times a. A is 2, so it's going to be 2 times 2, which happens to be 4. So our x value here ends up being negative 7 over 4, which is the same thing as negative 1.75. So that gives us the x part. So if I'm writing my point here, I can say negative 7 over 4. For the y part, we need to plug this in. So what I'm going to do is rewrite my equation where I'm plugging in negative 7 over 4. Luckily, I can use my calculator for this, and it'll help out a lot. So we end up with, let's see, it's 2 times x squared, well, that's negative 7 over 4 squared, plus 7, parentheses, negative 7 over 4, plus 3. And to figure this out, I'm going to use my calculator. There we go. Hopefully you can see the calculator just fine. So I'm just going to type this in as is. We've got 2 parentheses. I'm going to type a fraction bar, do negative 7 over 4. And this needs to be squared. Don't forget that squared. Then I've got plus 7 parentheses, fraction bar, negative 7 over 4. It's important that you put that parentheses in there or else the calculator is going to get confused. And then we are going to add on 3, plus 3. I'm going to hit enter, and that says my answer is negative 25 over 8. Negative 25 over 8. So that means our y value is negative 25 over 8. And with this information, we can actually come up with a graph for this equation. So let me go ahead and scroll this up a bit so that I can actually draw out a graph. Let's move this over here. All right, so here's my little graph. Let me zoom in a bit so we can see it a little better. All right, awesome. So the things we know. First of all, we know my y-intercept. Well, we said the y-intercept was going to be 3. So I'm going to start off by putting a little dot at 3. I know it's going to hit at 3. I also know that my vertex is negative 7 over 4, which is about negative 1 3/4, so about right here. And then down negative 25 over 8, which is a little more than 3, so negative 3-ish. So it should be about, and we've got fractions, so we're going to have to estimate here. It's going to be about right there. What this tells me is that, and it's kind of tough to see, so let me draw the axes in there. The axes kind of go like this. I've got another one right here. All right, so what this tells me is that because it's a smiley face, I know it's going to start at the vertex, and let's actually do this in blue. It's going to start at the vertex and go up, and it's not going to cross the y-axis until it hits this point. That's the y-intercept. And then because parabolas are symmetrical, meaning they're the same on both sides, we know that this side also looks something like that. This has been an example of how to find all the different parts of a parabola. To be able to be successful on this test, what you're going to need is to be able to find the y-intercept. You're going to have to find the roots or the x-intercepts, which we'll talk about in a second. You'll need to be able to find the vertex. You'll need to be able to, what else will you need to be able to do? Vertex, y-intercept. You'll need to be able to figure out the shape. You'll need to be able to talk about domain and range. Let's talk about those real quick. Domain is the list of all the x values that work. Now, because of the arrows here, we know that this is going to keep going on forever. It's going to go up faster than it goes this way, but it is eventually going to hit all these x values. We see we get to all these x values. And on the other side, we're also going to hit all these x values. All the x values are eventually going to get hit. So our domain, in this case, domain, is going to be from negative infinity all the way to positive infinity. That's our domain. The range, however, is the list of all the y values. So let's look at what y values we actually hit. Well, the lowest y value we get to, this is our lowest point right here, so the lowest y value we get to is right here. On the other hand, the highest y value we get to goes on forever. So for range, my range, I'm going to have my lowest number being negative, well, it's actually going to be negative 25 over 8, which we said is a little more than 3. I'm going to actually write the real number, negative 25 over 8. The biggest is going to be infinity. A quick reminder about domain and range, though, is we have to ask ourselves, with these intervals, are we actually hitting the number? Now, with domain, it's easy. You can't actually hit infinity. It's not really a number. So, with here, we use these parentheses instead of brackets. For range, however, do we actually get to negative 25.8? Well, yeah, that's the vertex. We definitely have a point there. So, instead of it being a parentheses, I need to make it a bracket. That means I do touch that number. It's like saying less than or equal to, or greater than or equal to. So that's domain and range. So we talked about shape, we talked about y-intercept, we talked about x and y intercepts. Let's go into detail about how to find those x-intercepts. Looking at a graph, we can say, oh, obviously the x-intercepts are here and here. But what if you're not given a graph? What I'm going to do is clear off this picture and show you how I would find the x-intercepts for something. So here, let me clear this off. And I'm actually going to switch to a different problem. Give me 1 second. All right, here, let's take a look at this example right here. We'll talk about 3 ways of finding the x-intercepts. So, there are 3 words that we use to describe the x-intercepts. We call them x-intercepts, of course. We'll also sometimes call them zeros. And we call them zeros because it's when y is 0. It's when the thing equals 0. We'll also call them roots. Think of it like a root is something that something is built on. So these are the roots. The x-intercepts are things that it's built on. And last, we'll call them solutions. So if you ever hear me ask for any of these things, you're going to solve it in one of these 3 ways. All right, so first way, if I give you a graph, this is the easiest way, like easiest ever. If you've got access to a graph, then the x-intercepts are just the x-intercepts. It's that right there. So my answer for this one would be x equals negative 3 and 2. Ta-da! So if you're given a graph, it's actually very easy to figure out. Now if you're given something like this is called the factored form of a quadratic. So this is the factored form. It's already broken up into pieces. It's already factored. So let me real quick jump over to this one and show you how I would factor this. We've gone over examples of this before in Unit 4, but let me show you a quick refresher. So to factor something, what you do is you start off by drawing your box, a little 4x4 box. Over here in the box, you put your a term, which is x squared. Sorry, not the a term, I mean the whole term here, x squared. And then over here, you'll put c, which is 3. Then, what we need to do is multiply these together, which in this case, it's x squared and 3, so it's 3x squared. And then find the factors of it. Our factors of, let's just look at 3 for now. Our factors of 3 are 1 and 3, and that's it. Because 3 is actually a special number. It's prime, which means that it's only got these factors. If it were a number like 60, we would have a lot more factors to look at. So what we need to do is pick the pair of factors. In this case, there's only one option. But we'll pick the pair of factors that add up to b. In this case, b is negative 4. Now, does 1 and 3 add up to negative 4? No, it adds up to regular 4. So what we do is we'd ask ourselves, is there another possibility? Are there other factors of 3? Are there other pairs of numbers that multiply to positive 3? And there is actually. We have another option, and it's negative 1 and negative 3. Negative 1 times negative 3 is still positive 3, because a negative times a negative is a positive. So we would still end up with positive 3. These are another option. And this option does add up to negative 4. So I found my pair. What I'm going to do is write this pair in here, including an x. So negative 1x and negative 3x. It's important to include the x's because we need it to actually multiply to 3x squared. So it actually does have an x on there. But number-wise, we can kind of ignore that part. All right, so from here, I need to pull out what I can. Let me change color real quick. Let's go with fuchsia. In this top row, the only thing they have in common are x. I mean, technically 1x, but do I really need to pull out a 1? Nah. So I'm going to pull out x. Down here, we see that there's a 3 in common. Actually, we see that this one's negative, but we'll deal with that in a second. Let's just say we pull out 3. Okay? Over here, still they only have an x in common, and over here, they don't really have anything in common, and we have to pull something out. So earlier, they had x and 1 in common, and we pulled out x. In this one, they don't have anything in common, so let's just pull out 1. Now, whenever you do this, you must check to see if it works. Does x times x equal x squared? Yeah. Does x times 1 equal negative 1x? Well, no. Okay, so I must have made a mistake. Let's make sure that this is negative. Okay? Let's see if it still works. X times x equals this? Good. X times negative 1 is negative 1x? Good. What about 3 times x is negative 3x? Nope, that doesn't work. It needs to be negative. So let's check to make sure everything works again. Every time I make a change, I should check everything. This times this equals this. This times this equals this. Good. This times this equals this. Good. What about negative 3 and negative 1 equals 3? Yes, that also works. So our factored version of this would be x minus 1 and x minus 3. Factoring is one of the options to find out our x-intercepts. The way we do it from here, once we've got a factored version, see we've got a factored version. Once we've got a factored version, we just ask ourselves, okay, when does this part equal 0? When would x plus 10 equal 0? Well, to do that, I'll just subtract 10 off of both sides and end up with x equals negative 10. And then for this one, I'll say, when does x minus 3 equal 0? Well, again, I'm going to add 3 to both sides, plus 3 plus 3. It's going to cancel out, giving me x equals 3. So we know our x-intercepts are, x is negative 10 and 3. So those are our x-intercepts for that. In this case, our x-intercepts would be 1 and positive 3. Positive 1 and positive 3. But I also want to show off the third method here. That third method is finding it's using the quadratic formula. We've done this a lot in class very recently, but it's worth going over again. So the way I'm going to do this, here, let me erase the board real quick. All right. So we're using this one right here. Our first thing we need to do is make sure it's equal to 0. It's also okay if it's equal to like g of x or something like that. That's fine too. As long as it's not equal to like 3 times x or 7 or 12. It's got to be like 0 or this. So if this passes the first check, yes, it's equal to 0. Our next thing to do, next thing I like to do if I'm like taking extra time on this, and since this is a video, I might as well. I'm going to record what A, B, and C are. I know I'm writing this over in this box, but I'm still talking about this equation. A in this case, if there's no number there, you say A is 1. If there's no number in front of it, you ask yourself, okay, how many x squareds do I have? I've got 1x squared, so 1. B, in this case, is going to be negative 4. It's important that we keep that negative attached to it. And then C is positive 3. By the way, if there wasn't an x squared at all, we would say that there's 0 x squareds. A would be 0. B, if this term wasn't there at all, I would say that there's 0 x's, so B would be 0. All right, so from here, what we're going to end up doing is, let's do this, and then close that up. We're going to write out the quadratic equation. You guys have heard me sing it a million times, but you're going to hear it again. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2 times A. Solve, solve, solve. All right, what we're going to do from here is plug in our numbers. All right, so let's go back to this. So X is going to equal the opposite of B. B is negative 4, so the opposite of negative 4 is going to be positive 4. Plus or minus the square root of B squared. That's negative 4 squared. Negative 4 squared. This must be in parentheses or else you're going to get the wrong answer. Minus 4 times A, which we said is 1, times C, which we said is 3. And that's all over 2 times A, which is 1. Now I could try and do this by hand, and there's no shame in that, no problem with that. But let me show you how to do it on the calculator. This is how we spend most of today's lesson, by doing this on the calculator. All right, so here I've got a calculator. It's cleared up. All right, so what I'm going to do is type this in verbatim, and I'm going to start off by doing my fraction. I'm going to hit the little fraction button, this n over d, boop, fraction. By the way, if you hit the fraction bar and it does this, here's how you fix it. If it does a slash instead, go to mode, go down to where it says math print, and hit enter. Now when I hit n over d, it makes a fraction. All right, on top we've got 4. I'm going to have to do both the plus and the minus. I'm going to do the plus first. 4 plus the square root of parentheses, negative 4 squared. Oops, sorry, that squared needs to go inside the parentheses. Parentheses squared. All right, minus 4 parentheses 1 parentheses 3. Something you need to be very careful of. This right here is a minus, not a negative. If you use the negative button instead of the minus button, the calculator will actually think you're multiplying by a negative 4 instead of subtracting 4. So be careful what you type in there. All right, now I'm going to use my arrow keys to go down, and then have this right here, which is 2 times 1. Do I really need to write out parentheses 1? No. But then I hit enter, and it gives me my answer. One of them is going to be 3. So to find the other answer, I'm going to use my arrow keys to go up, and then highlight the thing I typed, click enter, and that will retype it for me. Then I'll just use my arrow keys to go back to that plus and change it to a minus. I've got 1 as my second answer. So, in this example, which we actually found this out earlier using the factoring method, we see that x is 3 and 1. I do not care the order that you put these in. You could put 1 and 3 or 3 and 1. What you definitely shouldn't do, you should not do this, is write out it as a point. This is not a point. This is not a point. It's a list. If you want, you can put a comma in between there, but don't put parentheses around it because that means it's a point or an interval, and this is not that. I would definitely recommend you just write the word and in there, and then there'll be no confusion. All right, I hope this has clarified this unit for you guys. If you guys have any other questions on this, please talk about them with me. I would love to help you on them. Just either send me an email or talk to me about them after class.